Hello student, this is lecture of analytical chemistry. We have started the second chapter, that is HPLC, high performance liquid chromatography. In previous lecture we have go through the introduction of HPLC and instrumentation part, the major equipments that we have already discussed with you. Then mobile phase or mobile phase reservoir in HPLC, then injection systems in HPLC that we already discussed in our previous lecture. Now in this lecture we will see the third instrumentation part, that is column in HPLC. So let us look over it. In HPLC technique, the column is made up of stainless steel having 15 to 30 centimeter dimension length. The stationary phase in the packed column, and it is usually solid adsorbent. In some cases, solid adsorbent is packed with thin layer of water. Thus, the mode of separation in HPLC technique is partition coefficient. That means the analyte is distributed between the stationary and mobile phase through the partition coefficient. Now, the choice of column. So, which column we have to select? Column selection is based on primarily the solubility of analyte in the solvent. In HPLC analyte, artificially organic molecules that have vary in size, polarity and functionality. This feature is govern the solubility of analyte in the solvent that ranges from high polar to non-polar. Some analyte are ionic functionality. Ionic analyte often to required to maintain the pH or ionic strength in the mobile phase for the good separation in the chromatography. As in other chromatographic technique, in HPLC, mobile phase with the test sample is moved through the stationary phase, and the compound in the test sample is separated in the column. So mobile phase plays a role as a carrier for the test sample. According to polarity and solubility, the test sample is separated in the column eluted at different time interval. We called as retention time. Types of column. There are two types of column. First is silica gel HPLC column. This type of column are used as earlier for the liquid chromatography. It has wide range of application. However, it can be only used under the certain conditions, that is pH range from 2 to 7.5 and the temperature must be less than 60 degrees Celsius. Other than this condition, this column will be failed, that will not work. For that, the second column is chemically bonded stationary phase. So in this chemically bonded stationary phase, again there are two types, that is non-polar bonded HPLC column and polar bonded HPLC column. So let us say the non-polar bonded HPLC column. The most widely HPLC column contains C1 to C22. This is organic material. Among them, that C18 column was most commonly used non-polar reverse phase column. It has very good properties, good separation efficiency. It has wide range of application and very good separation effect. Second is polar bonded HPLC column. In this column commonly used as a functional group. That means the amino group, cyno group, dial group. These functional groups are embedded in this stationary phase. The selectivity of the amino column first appear as a strong hydrogen bonding ability, then acidic medium, because in ionic polar compound, so it should, or ionic functional compound, it should maintain the pH and the ionic strength. So that why the acidic medium is required. The weak anion exchange and ternary amines of hydroxyl group interact using acetonitrile water system. It is possible to separate a flash monosaccharide, disaccharide or starch material, etc. because this material have functional group. Second, separation characteristic of cyno column are similar to the silica gel Hplc column, but the polarity relatively weak. This advantages for good gradient illusion composition. Third functional polar column will be the dial based Hplc column. That means dial functional group are there. This is generally hydrolysis product of a glycerol oxypolysilane bonded phase, which has a good separation efficiency for the organic acid and certain polymers, biomolecules, proteins, etc. So next part of HPLC is detector system. Detector in HPLC, that detector record the relative concentration of different components of the test sample or analyte in the form of their retention time. Retention time is the time taken by the compound to elute from the column. Retention time is calculated from the time of injection until the compound is eluted. So detection is based on several different physical properties like UV absorptivity, refractive index, fluorescence, radioactivity, IR and electrochemical gradient. Depending on the characteristic of this mixture and physical properties has different, so according to these physico-chemical properties the analyte will be detected. The detector have a characteristic property, so it must show the response for all component in the mixture. It must be linear response with function of concentration. Temperature variation must not affect it much. It must be independent of eluent composition. It may be solvent phase, may be gradient, so that will not affected by this gradient method. It must be capable to tracing the very lower concentration. That means dilute solution can also analyze. The peak must be not be widened. Resolution is good. It must produce stable and reproducible signal. It should be non-destructive because then separated analyte can use for the further characterization for mass, IR, etc. So here we stop the lecture. Next lecture we will see the choice of stationary phase, choice of mobile phase and application of the